onward with today's topic, which is the Conext CL 18 and 25 kW, 18 through 25 kW inverters. So first off, this is a three-phase grid tie inverter. So I'm going to make the assumption here that you know what a grid tie inverter is versus a battery-based inverter, but this is a grid tie only battery-based or battery-less inverter, a current source, if you will, synchronous, and specifically, it is three-phase. So we'll get into voltage requirements and that sort of thing in a little bit, but suffice it to say, this is not a single-phase residential size inverter. This is a larger three-phase inverter. So the two top units you see are our UL versions, or North American, whatever you want to call them, that have CSA and UL approvals. And though they work with 1,000-volt arrays, typically in the UL world, most of the applications so far, I think, are 600-volt. I mean, that might vary by jurisdiction, but be aware you could run this at 1,000 volts. But the window, the MPPT window, is definitely wide enough to operate it at the 600-volt level. So it comes in two flavors for North America, 18 kW and 25 kW, which I think is fairly self-explanatory. So the part number is fairly straightforward. CL 18,000, I say 18,000 North America, and the CL 25,000 North America. So I think I said 18. So 18 kW and 25 kW. So that's the U.S. versions. The rest of world, or IEC versions, that have all the necessary IEC approvals, which typically running 1,000-volt arrays across the board, are what we call the CL 20,000E, which is a 20 kW inverter, and the CL 25,000E, which is 25 kW. And other than differences between the smaller inverters, you're going to see that there's a little bit difference in the max power point tracking window as well. So applications, like I said, battery-based inverters are a little bit more complex in their applications. Really, when it comes to applications in a battery-less inverter, it comes down to the size of the installation. You've got ground mount versus rooftop, large systems, parkade structures, maybe a little bit smaller, multi-megawatt. And there was a time, actually, I'm going to make myself sound old here, but when I used to do training on central inverters, and at the time a central inverter was 10 kW and up, big ground mount inverter. Well, things have changed. Things have gotten much lighter. High frequency inverter topology has helped bring larger units to the string inverter world, I guess, three-phase and single-phase. But so though we think of these inverters of this size as for instance, parkade structures, for 18, 20 kW single inverter applications, and that is very valid. We can go all the way up, and people do quite frequently, to multi-megawatt systems where instead of a central inverter, we have multiple, smaller three-phase string inverters. There's a lot of advantages to this. One of them, particularly if you're in a remote location, though many grid tie systems aren't, but there are those that are. And if you're in a very remote location, a large central inverter, when it goes down, the whole system is shut down until a service person comes and fixes it. Where going to a decentralized solution like the CL inverter, basically the inverter can be swapped out very simply, which I'll talk about how that is done later. But the bottom line is there's a lot of advantages, and not necessarily going to the extreme, in my opinion, anyway, of microinverters where you have an inverter on every panel and multi-megawatt, but going to multi-megawatt systems. So commercial rooftops, they work great because you can mount them up on the roof. Decentralized, mounting at the end of the strings like we see here, and parkade structures where you put them underneath. So very flexible. I think that the industry has changed, and central inverters for large solar farms might be the answer, but for most other applications, I think the larger or smaller three-phase string inverters are probably a better solution. So in a nutshell, what we have here, when you see this Conext CL inverter, is really two major components, and we see a split here. We've got kind of a highlight there in the bottom of the wiring box. The upper section is actually all the power electronics and such, and it bolts to the wiring box. And this is something that up until recently was only done at the residential small scale. But now, even with Conext CL, we can do this at the three-phase, commercial scale. And the advantage to this is, in the highly unlikely event of an inverter failure, we can actually remove the top portion very simply with a few like bolts, the kind of structures that go into the wiring box that bolt the main section on top there without really removing wires. Makes swapping the inverter very simple. I've never actually timed it, but I'm going to guess that it's a 5-minute operation. Please forgive me if I've exaggerated. But it's an integrated wiring box, so once you mount the wiring box and do the wiring there, the upper section could be replaced very simply. So again, back to the idea of these large fields where you have somebody maintaining them. If an inverter were to go down, it's a very simple process to replace it. Now, that wiring box has 5 different options, each for North America and for the rest of the world, to support customers' different needs. And we're going to talk about that extensively. I won't talk about it now. Touch-safe fuse holders as an option. Again, that's into the 5 different optionals, as well as a DC switch being integrated. These are options. Some installers prefer them basically naked without any of this because maybe the infrastructure is already in place, or because they have an affinity with a particular type of product that they want to use instead of our internals. They can. We make that optional. DC arc fault protection detection is available as an option on the UL models only. That's not a requirement rest of the world. So AC and DC surge protection as an option, both for the IEC and the North American models, and then both side and both bottom and side conduit cabling for the UL models only. Now, I'm not 100% why that isn't for the IEC model, but I'm sure it has to do with local, with wiring regulations. So the wiring box replaces an external DC wiring box. And like I said, there's different models. There's actually 5 different models of the box for each North American and for the IEC market. So on the left side here, we see the DC spring terminals that come. This would be if you were purchasing the standard model, the basic model. The actual name is eluding me right now, but we'll get to that. Where you can, if you're just tying in your array from an external combiner box as well as your AC coming straight in, that's what you would have. So you see on the left-hand side. Optionally, you can have touch-safe fuse holders for the different strings coming in, and that's on the upgraded models as well. There is 2 MPPTs in the unit. I don't remember how much. I've actually had to pare down some presentations to try to fit into an hour, and so I think I may have skipped that to a certain degree, but the unit does have, all these do have 2 MPPTs, which can be bridged together for a single MPPT, which would be potentially more useful in a large field application. But if there are different planes of array and such, you can split the MPPTs and do 2 MPPTs. So there's a jumper included for tying them together in the event that you do. So arc fault protection, which is what we see, surge arrestor. Arc fault detection is on the DC inputs. For the UL models is optional. For the plus version, and I'll see what the plus version is in a moment or in a while. Surge protection devices on the DC inputs and AC outputs on the optimum version wiring boxes. And again, I'm going to have a table to show you the different models, but it's really important. It's probably the largest decision when buying the CL inverter is going to be which wiring box option you have. So we do spend a fair amount of time on that in this presentation. So again, this is not a installation and commissioning presentation at this point, though that will come at a later time. So wiring box options for the North American models. What I have down below here is sort of a little statement to try to make it a little bit less, well, not less confusing, but so in essence, the base model of the wiring box, both for North America, right now we're talking about North America, includes just AC terminals and DC terminals with no fuses. This is for the installers that have external combiner boxes already installed. They've already got their AC disconnects. They've got their DC disconnects, all that externally, and they don't want to buy them and have to be burdened with the cost. So we do make that available at a lower cost. In some developing nations, I've seen that they use completely different standards for disconnecting, and quite often cost savings. And so they opt to use the base model with just, again, DC terminals, no fuses, AC terminals, nothing else, not even a disconnect. So that's one option. Now the essential model for the US version, now that includes the DC disconnect switch as well as touch-safe fuses for the strings, which it's basically 4 strings per MPPT, or 2 strings per MPPT. Ooh, we'll get to that. But the total, we'll get to that. Right off the top of my head. So in the Plus version to the US Essential, that adds DC arc fault protection. So as I said earlier, the Plus in the US version means arc fault protection. Essential means AC and DC, or DC disconnect as well as DC touch-safe fuses. If you add the Optimum, now we're also adding AC. This is a bit confusing to me as well. We're also adding, we add AC terminals, DC terminals, we have the DC touch-safe fuses, as well as the DC and AC surge protection. Okay, this is why I made my statement at the bottom to clarify. Plus, again, adds the arc fault. So, to summarize all that, base has only AC and DC terminals. Everything else has a DC disconnect and DC touch-safe fuses and terminals. The Optimum, on top of what the Essential adds, DC and AC surge protection. The Plus always adds arc fault when necessary. So, I know that's a bit confusing, and I maybe could have said that a little better, but I think it's pretty clear when you have requirements, you'll look at this and say, well, I need that, I need that, I need that, so I need this inverter. So most people, I think, in North America will probably opt for the Optimum Plus, as arc fault detection is required, and DC and AC surge protection, if not required, is probably preferable. So my guess is North America, Optimum Plus is probably going to be the largest, but I've been wrong before. Now, onto the IEC models, the rest of the world. This is a little bit different because arc fault detection, for one, is not available, nor required, nor necessary for the rest of the world. And so the base model, again, has just AC and DC terminals. If you add Essential, what you're adding is the touch-safe fuses again. The Essential Plus now adds MC4 connectors. That's the plus on the rest of the world. So the major difference, Catherine Chen, and this is an important one. We have product management raising their hands, so I know that this is an important feature. As a matter of fact, Catherine, if you want to come off mute and chime in, please feel free to join me. Oh, okay.
Can you hear me now?
Oh, I can hear you now, yes.
Yeah, just one correction, Roy, and the rest of others. The connector we use for DC side is actually the Molex connector, which is compatible with MC4 connector, with MC connector, but we will not call it MC connector. It's a Molex connector. And I know some of the, you can change it, Roy. And I know some of the countries, like in Germany, in Australia, in France, probably in US as well, the regulation said you have to use the same brand connectors for male, female as a pair. So the 2 ends of the connectors must come from the same brand. So this is one thing I would like to highlight here to avoid any confusion. And if installer customer want us to provide another part of their connectors, we can definitely help. We have their SKU number for the Molex connector, so customer can directly place order on us as accessory, and they will get the full pair of connectors.
Oh, okay. Thank you. As a matter of fact, your audio is coming through loud and clear, and as you know as well as I do, grid tie is not my strength. I'm glad you're here. Please feel free to chime in at any time. I welcome your expertise. So, anyway, we'll march on. So that clarifies that. One of the things that people always ask me is, when will your presentation be done? And I used to say right before the presentation. Now I've started saying it'll be done right after the presentation. So I'm not too proud to correct things as I go. So onward. So base model adds is AC and DC terminals again, just the DC terminals. All others, everything else now adds the DC terminals, touch-safe fuses. The Optimum adds the surge protection, and the Plus adds the Molex. Molex that are compatible. Well, as we just spoke, I got to clarify that a little bit better, but so that adds the Molex connector. So a little bit different than the North American models as far as what the models are based on the requirements. So specifications for all the units. Probably the most looked at specification on any grid tie inverter is the full power MPPT voltage range. That's the one that gets the most press. So what we see here is that the CL 20 kWe, which is the rest of world IEC version, has a full power MPPT range of 350 to 800. So there's your MPPT range. Full operating voltage range up to 1,000 volts. It's 1,000 volts max open circuit. It has, this is where I may have been wrong earlier, so number of MPPTs, 2 MPPTs, strings per MPPT, 4. So a total of 8 inputs. So the touch-safe fuses was 8. Maximum input current per MPPT is 31 amps. Absolute short circuit current per MPPT, 40 amps. Nominal DC input power, 21.5 kW. So we look at the 25 kW unit in comparison has a little bit tighter voltage range, 430 to 800. Same max open circuit power rating. The same max short circuit current. Quite a few of the other numbers are different other than the nominal DC input power. The whole thing shifted on me here. The CL 1800 North American is now 250 to 1000 volt range. So the North American models both have, I'm sorry, I got ahead of myself. 300 to 800 volt MPPT voltage range, up to 1000 volts. So most installations in UL territory are going to be 600. Again, 2 MPPT inputs, 4 strings per MPPT. The currents you can see there, I don't need to read all those to you, but the important one is the MPPT windows. Now, if we have time today, I can open up and just give you a brief overview of our Conext Designer program, and I would recommend you download it. It's very easy to find. One of the things I like is the SE Solar, so www.sesolar.com website is very easy to navigate. And if you go under products, the Conext Designer program is free, and you'll find it under the products tab, and you can download it very simply. It's a very useful program for doing your string sizing. So plug in your module, temperature, your azimuths, and things like that, and it'll give you your numbers, and it'll tell you if what you're proposing is good or bad, or and things like that. So we have a very nice string sizing program, which I'm more familiar with it for doing charge controllers. But it is much the same. String sizing is string sizing when you get down to it. So peak efficiency, 98.3 efficiency peak. For the European standards, we would call it 98%. IP65, the electronic section. So that's the forward section. So the electronics are more sealed than the rear section. The rear section is IP54, which is plenty because there's not any sensitive electronics back there. So it's different enclosure ratings front and back. Weight of the inverter is 54 kilos. The wiring box itself is 15, but they don't have to be lifted to the same time. You can mount the wiring box first and then mount the inverter on top of that. Ambient air temperature, -25 to 60 degrees C for operation. Communication interface is RS-45 Modbus, Ethernet, and there's a USB in there for doing things like firmware upgrades and pull some data logging off of, as well as a dry contact. I may get Catherine to chime in on what the dry contact can be used for. I believe it's used for error reporting. Correct me if I'm wrong. Okay, I didn't get corrected. Okay. I have a hand. Yes.
Just one additional information provided to everyone is about the number of MPPT and the streams per MPPT. And for base model, we still have 2 MPPTs, but the streams per MPPT for base model is only 1. So for base model, we provide 2 inputs, and each input will be connected to 1 independent MPPT. So this is kind of an exception for base model. We have 2 MPPTs, and each MPPT we have only 1 stream. For the rest of other SKUs, we have 2 MPPTs. Each MPPT, we have 4 streams.
Got it. Now, with the base model, can you still bridge the MPPTs together?
Yes.
Okay.
And also one additional information for everyone is about the functionality of dry contact. The dry contact can be connected to any inverter event, any user setting inverter event, like temperature setting limit, power level setting limit, or any inverter status like online, offline event. All this can be configurable, and customer can use this dry contact to control the inverter by those events.
Perfect.
Thank you.
All right, thank you. So, an overview of everything we've got here. 25 kW for 1,000-volt DC application. Transformerless. In the batteryless inverter world, transformerless inverters are lighter, more efficient. In the battery-based world, where I'm more familiar with, actually, transformer-based inverters are the rule still, but in this world, they are not. So 98% Euro efficiency, 98.4% peak, 2 independent MPPTs. Supports a high array to inverter ratio, so you can oversize quite a bit, probably more even than you should in some applications without damaging the inverter. For getting that longer day of operation. Sometimes installers will want to oversize the inverter because they find that modules are sometimes cheaper than they can basically stretch out the bell curve during the day, if you will. -25 to 60 degrees C operation, so good thermal performance. IP65 for outdoor installation, so it doesn't have to be indoors. It can be up there on the array. Very light, 54 kilos for this size inverter. Like I said, back in the days when I started doing central inverters, a 10 kW inverter was installed with a forklift on a cement pad, where now one person can lift a 25 kW inverter up onto the wall. The wiring box is integrated. This is an important feature. Integrated wiring box eliminates the cost of DC combiner box. So though the models with the combiner and the DC inputs is more expensive than the base model, of course. If you look at the cost of adding external as well as the complexity of it, I think you'll, in most cases, probably opt to the most loaded version of the unit. unless there's, extenuating circumstances, like, for instance, already installed balance of system replacing another inverter. 5 options. So if that isn't what you want, we do have options for that. Touch safe fuse holders. These are nice. You're able to now be aware that you don't want to open these under load. I've seen the results of that, and it's not good. These are not to be opened under load, so they are not a disconnect. DC switch is integrated, so that doesn't have to be added externally if you choose that option. AC and DC surge protection is an option. The MC4, well, the Molex connector is an option. And then the arc fault on the UL models. So monitoring and control is something I'm going to speak a little bit more of towards the end, but basically on board we've got a simple LCD display, which you can do quite a bit with. You can basically go through and commission the system from the display. You can get all the production numbers as well as faults and errors and log files off of here. There's also, like I said, there's a USB host underneath where you can plug in and download data as well as upgrade firmware. But there's a built-in web server and data logger. So you don't need up to 8 inverters. We don't need to have any external hardware other than IT hardware, routers and things, to do data monitoring. So that's going to keep the cost down on the smaller systems, where you can actually do data logging and monitoring without any additional hardware, even using our Conext Insight web portal, which I'll talk a little bit more about. Remote inverter on and off. I believe, now Catherine may want to chime in on this one. Can the aux port be used for the remote on and off? Is that one of the functions of the remote of the aux port?
Yeah, these are, there is one interface port called RPO, okay. which has support these remote inverter on and off functions. Actually, I'm not sure which, it is very remote. The maximum, the permissible distance from RPO switch from the inverter location should be no more than 30 meters. So customer can control the inverters on and off through this RPO switch, but the distance is within 30 meters. So RPO should be connected. Yeah, go ahead.
Oh, I was going to say that's a separate port though from the aux port.
Right. So we have our COM card. There are several interfaces. The dry relay is one of them. The RPO is another. So the RPO should be connected to a switch which has a normally closed contact.
Got it. Okay. Thank you. So easy to connect to third-party monitoring as well. Full grid management features, which basically we have the ability to inject VARs. Not again my strong point. Something I haven't really dealt with much in my career. SunSpec Alliance Modbus map compatible. If you need that, we have it available. I'm not sure how that would affect you. Probably from third-party monitoring software is where that's going to be the most relevant thing. Communication ports, like I said, we've got an Ethernet port that ties into your router and off to your, you can do your web monitoring. RS-45 port, there's 2 of those for daisy chaining for Modbus. We have a USB port, host and device, primarily for upgrading firmware and for pulling data logging off of the inverter. The dry contact we spoke of, the remote power on-off contact, separate, we just got a good one on that. And there's also a surge protector monitoring contact. And one of the things that I was told to be careful of is if you buy the model with the surge protector, make sure you connect the wire. There's a little wire that's in the back of the wiring box there behind, I believe it hides behind here, that needs to be connected to the inverter. And that is so that the inverter can know if the surge protection has has well, been used and give you a warning on the inverter. So make sure you plug that in. So there's kind of a brief product overview. So we've got, here's kind of a graphic display of the different models we talked about. So the base model, you can see it's very simple inside there. We've basically got just the spring cage clamp AC and DC connectors. Again, one MPPT input, or one pair for each MPPT input that can be bridged. External fusing and protection required. The essential adds are touch-safe fuse holders, a DC disconnect. You can see it gets a little bit more full in the box now. And the MPPT paralleling terminal block, which is, I'm fairly certain, right here. So it could be, or is it between the, yeah, I don't remember. I did this once and I can't remember where it was. DC switch, MPPT paralleling terminal block, MC4 DC connector for the Essential IC model. Again, this is incorrect. It's a Molex. The Optimum, and that adds our surge protection, as well as the Plus adds the Molex for the rest of the world, and the arc fault for the North American model. So there's kind of a graphical display of what we spoke about. So, DC input operating voltage ranges. So what we have here, any grid tie inverter is going to have an area where it wants to operate. And that's going to be the center here, where we see full MPPT power operating range. And we can see now the maximum on all units is 800 volts. Now we go to the left there, we can see the minimum MPPT operating range for max power output for each of the different units. So as they get larger or higher, bigger, that range gets a bit tighter. But the 18 UL is 300 volts minimum operating. That's minimum max power, so minimum MPPT operating range. The 20 is 350 for the IEC model. It's 430 for the 25 kWe model, and 500 volts for the 25 kWUL model. Now, they will all operate outside that range, and that's our area here we see D-rated. So from 250 up, it will operate, but at a D-rated from peak efficiency. So we really want to size the array so that our MPPT voltage range in hottest climate is up there above these numbers you see below. So when you do the sizing program, it's going to give you warnings if you're outside that. But the key is, as with you want to keep your array's MPPT, max power point tracking voltage range, the VMP. We want to keep that above these numbers in the hottest conditions, because we have, as the temperature rises, of course, the VMP goes down. So we want to make sure that. So on the upper end, between 800 and 950, if the MPPT range is up in there, we're going to operate again D-rated, but we will be operating. But if we go above 950, it's not going to operate for MPPT range. But once we get above 1,000 volts, now that's when the damage starts occurring. And I don't know, I get asked quite frequently about these max open circuit voltage ranges and say, how much can I go above it without damaging the inverter? And if I did know the answer to that, I would not tell you, because I want you to design it to not get up there. So when you're doing your design, make sure your coldest climate, that's going to be your early morning time, your coldest daytime temperature, and how it affects your open circuit voltage does not go over that 1,000 volt range. If it does, damage can occur to the inverter. Not a good situation. So the key to sizing your array, of course, and string sizing is to keep the VMP above the minimum in the hottest days, below the maximum VOC in the coldest days, or coldest time. So really, in essence, other than power, that is your sizing that's required for grid tie in general. So DC current is also important. So there are three important DC input current specifications that we're going to be dealing with. So it's going to be the normal operating DC current range, the maximum operating DC current range, and the absolute maximum DC input short circuit current rating of the inverter. So we, again, when sizing the inverter, in this program, the Conext Designer is going to show you this. And it's very simple. I won't get into that today because that's going to be a topic for another webinar, really. I mean, if we have a little bit of time, I could open up and show it to you, but we won't get in depth. But it's going to give you the ability to model an array and come up with your maximum operating DC input current, your absolute maximum, and your normal. And it's going to give you these numbers. So the IEC version, this is a bit of a confusing slide here. The absolute maximum DC current, so this is your short circuit current, is 40 amps per MPPT on the IEC version, or 77 amps if you're paralleling. So if you're only using one input, you're paralleling the two inputs. So it seems like it's a little bit lower, but that's still plenty to get your array. You're even oversizing your array, bringing it in. So that won't ever be an issue in a properly sized array. For the North American versions, it's 36 amps per MPPT, 72 if they're parallel. So the operating maximum, so this is where you want to try to keep things going, and the IEC is 31 amps, North American 26.5. So that's a little simpler. Again, by really going into the Conext Designer program, choosing the module that you plan to work with, as well as the inverter, entering your minimum, maximum temperatures, array orientation things, you can model this very comfortably. Grid tie is pretty straightforward in that respect, so I'm sure you know how to do that. This slide, I might just kind of skate through here. I planned to actually take it out. This is basically stating why there is a maximum DC current rating, and it comes down to components. You know, we've got DC connector maximum currents, we've got DC disconnect maximum currents, and then we've also got inverter componentry. So really, what it comes down to is that when we put maximum current and voltage ratings on an inverter, it's primarily due to input components, or it's due to componentry within the inverter, which means that if you exceed it, that you'll damage things. So, in essence, you know, use our Conext Designer. Even feel free to call our application engineering team and work with them when doing a first design or two. And that's the case with all inverters. You know, please feel free to do that. But the reason for it is we don't want to damage the inverter. So oversizing is done for different reasons. You know, there's inefficiencies. You've got some potentially shading issues. You've got you know, trying to stretch the day out and oversize it so that you can get more production on it. You know, if you have a application where you have a maximum inverter size that you can install, and so instead of just getting the peak of the bell curve, you want to stretch it out over the course of the day and get more overall energy harvest. There's various reasons that you want to oversize, and people do it every day. But the strings cannot be made longer. So when you're oversizing, you're not going to be going over the open circuit limits. And this is where those limits come into play. So if you're going to be oversizing, we don't want to do it on the voltage side and go above the limit. We're going to do it by adding strings and juggling the numbers. And again, this is where it comes down to using the Conext Designer. What you can do is you can actually change the modules per string, change the number of strings per MPPT or combined MPPT, and then it'll give you numbers that'll tell you, you know, if you are, you know, within a safe window or if not. But again here, if oversizing strings of less than 20% is required, then string lengths can be reduced. Really, this slide, I would just say that if you're looking at oversizing, and if you are, then use our designer program, come up with what looks like and makes sense to you, and again, call our application engineering team. So boost operation, this is something that's a little bit different in our inverter. So In some grid tie inverters, the voltage of the array, the VNP, needs to be above peak voltage to operate. But we actually have a boost circuit in the inverter, which means that we can actually operate. That's what gives us a little bit wider window on the lower end in particular. So if you look at IEC, so we got a 400 volt grid times 1.414, it means that you have a peak voltage of 565. So without boost, you would have to have a VMP, max power voltage of the array, above that 565. UL version, we're talking about a 480 volt grid, which would give us a 680 volt peak. So in the UL version, which would mean that you would have to have a maximum VNP of over 680. So the DC bus voltage in the inverter must be higher than the peak of the grid, including allowances for voltage drop in the inverter. If the inverter does not have a boost section, then the minimum array voltage must be at least 570 for IEC or 710 for UL. So we have a boost circuit, which gives us those lower numbers that we showed earlier, which I don't remember I don't have them memorized, but the different minimum VMP operating voltages. The reason we have the ability to go as low as we do is due to boost circuitry. So that's the thing there. So again, the grid voltage on the IEC is 23400. On the UL units is 277,480. So AC output voltage requirements. So for minimum for the North American versions is 244 per phase, 422. So if we go below that, we're not going to be able to operate. Minimum operating AC output voltage range. Nominal is 277,480. Right. So the minimum is 244, 422. The maximum for the UL units is 305, 528. So that's the maximum and minimum voltage ranges for the North American models. For the IEC, or what I call rest of world units, it's 184, 319 for the lower end, 276, 478 for the upper end. So here we have the AC grid voltages. So for Japan, US, Canada, if you're doing 277, 480, you can do that without a transformer. This slide is confusing to me. I thought I had it figured out earlier. But basically, rest of world, Germany, France, etc. Choose the IEC model version. Three-phase grid operating voltage. 500, I've never seen, but you would have to use a transformer. 600, I see that in Canada. You would use a US version connected to a transformer. Again, this is one of those situations, if you have a special requirement outside of the nominal voltages of the inverter, please get with our applications engineering team. They can straighten you out on this. But the units are 277, 400 for rest of world, 277, 480 for the US models. And here's just a kind of a table of different countries and their respective grid requirements. I won't read these to you. This will be recorded, so you can come up later and you can look at it if you don't know. But my guess is wherever you're working, you know what your grid requirements are. So, built-in monitoring. This is a nice feature. That's one of the things that I think has become more and more a differentiator, especially in the grid tie world, is monitoring and simplicity of monitoring and completeness of the monitoring, and less hardware is better. So we have built-in Ethernet connection. We can plug straight into your network switch router. Go out to your laptop. You can do any of the programming that's necessary. You can monitor. You can do it all just locally right there. Very straightforward, simple, no additional hardware. Inverter hardware. Very straightforward. We can also go out to a router, and then of course that gives you the ability to to go wireless and go to a tablet, your laptop, mobile phone. These are all local right now. Really, I would have to say zero investment, since what we're talking about is using your existing tablet, mobile phone, what have you, and assuming you already have a router, a wireless, this means no additional hardware necessary. What we see here on the right-hand side is this is one of these things, anytime that we're showing you a display of our interface, our computer interface for our inverters, be aware that they change frequently. We're always adding and updating and making things better and better, and that's why I have a date up there of August of 2014. So this probably is a bit dated of a slide, but it's going to be something very similar where we're going to be basically showing, it's a little bit smaller. I can't really see all, I can't read anything to you, but we're showing how much, carbon emissions you're saving, money you program into it, what your kilowatt hour rates are. You see our total real power, live there in the middle, total production for the inverter, all these things local, and this is all stored on the inverter as well. So for local monitoring, very simple. Oh, here's a better, here we blew it up after login. So we can see the money saved today, money saved total, and again, you'll be programming in the kilowatt hour rate. CO2, and that's another one you can program in what, how many kilowatt hours equal how much CO2. So that's another one you basically can set up for your application. We're showing the 3 different phase voltages and frequency, so we can get a real quick look at your grid quality. In the middle there, we see total real power from the inverter, as well as your online status, energy today, energy total on the inverter, how long it's been operating today, as well as real-time total. So this obviously was a fairly new unit that been only operating for 2 hours. And as far as, the total wattage on the PV, the different inputs separated out, the 2 MPTs and such. So very straightforward. Again, this is no additional hardware. This is basically a web page that is hosted inside of the inverter. You're just basically browsing into it, if you will. So there's also some more detailed information. Again, this is something that's changing, but just be aware that you'll be able to log right into the inverter, see your statuses and things. Just kind of more of a display of all the different things you'll be looking at once you get inside. But up to 8 inverters now, we can go out to, we can remotely go out to cloud in our Conext Insight. And so with up to 8 inverters going through a simple router out onto the cloud, we can do this monitoring basically for free. So up to 8 inverters, very straightforward, no additional hardware investment, no external control possible. So I mean, this is just for monitoring now, be aware. No sensors connected. So this would be for very simple production monitoring for free. Easy, simple connection, efficient up to say about 100 kW rooftop, which I believe with the 25 kW, really that would be up to about a 200 kW rooftop. Very simple, straightforward monitoring. With larger plants, and I'm not going to go into detail on this, but we have a product called the Smart Box. And what the Smart Box does, among other things, is aggregate inverter data from larger plants up to 64 inverters. And so this would give us the ability to monitor everything remotely via the web up to 64 inverters. But it's an additional piece of hardware. It's very small, but and this is for larger plants. So one Smart Box can monitor up to 64 devices. We can daisy chain. We can go larger as well using a master-slave routine. For even larger, but for a single Smart Box up to 64 inverters. Once remote monitoring Smart Box ES, the ES model brings in some external information. Again, I'm going to briefly go through this. It brings in the key here. The difference is the flexibility of choice of sensors. We bring in digital, analog, or RS-45. So we can bring in things like temperature sensors or radiant sensors, things like that, digitally, as opposed to here we can, I believe we can bring in external sensors if they are Modbus correct me if I'm wrong on that one, Catherine.
Yeah, the major difference between your SmartBox BA, the base model, and a SmartBox ES Essential model is for the Essential model, there are two other hardwares have been added. One is the power meter, short as PM. Another is additional I/O.
Oh, okay. So what monitoring can we, with the standard, the BA, the SmartBox BA, what can we bring in temp sensors and things like that?
Yes, we can.
Okay.
Just the ES will give our customer more flexibility and options to connect to more external sensors. Okay.
Got it. So we won't go too deep into that. The SmartBox in general is going to be a topic for a whole other presentation, I think, down the road. So basically just be aware that we have it. We're running short on time right now. Actually, we timed it. That's pretty much it. We've got a few minutes left here, and I think, especially since we have Catherine here, if anybody has any questions, please feel free to chime in. I ended it with 3 minutes to spare, so I think we're pretty close on time. Any questions out there at all? Make them tough, make them easy. Thank you, Eric. Those
Schneider,
Oh, what's that?
Roy, can you hear? I don't know if I have been.
I hear you fine. Yes.
Okay, Roy. My question is, you have shown on the slide showing the need to connect outside transformer when the voltage face to face is 220. That's the case in some of the grid utilities in Brazil. I would like only you to confirm that, please.
Oh, okay. So for Brazil, you have 220. So what does that come out to the 4 on the so it's 220 phase to neutral. So here we have that down. So 380. So I would assume, well, okay, so 220, and if we go here, Brazil choose IEC version. This slide is confusing to me. So the minimum operating voltage is 184,319. Catherine, am I correct in stating that in Brazil with 220/380 grid, that they would not need a transformer?
I think it is still needed. The IEC version is designed for a standard or nominal rated 400 volt AC. If the nominal AC grid is only 220, probably a step down transformer will be needed. Because 180, although it can cover 220, is not broad enough. It really depends on the grid. We need to know the range of the grid voltage.
Got it.
I think a 180, Roy and Emmanuel, actually, I think it's the phase voltage, not line to line.
Well, that's what he's saying. No,
voltage.
Right. No, but the voltage he's saying is 220 phase to neutral, line to line 380.
No, that's not correct. Actually, Roy, actually, the voltage you just mentioned, that's the most of the grid utilities in Brazil. However, you've got a state, São Paulo, so maybe 5 to 10% of the grid is 110 line to neutral and 220 line to line.
Oh,
so that's my question.
We're not talking. Oh no! One thing to keep in mind: CL inverter is a 3-phase inverter. So this product we have split phase product. It's 110, 220, 50, or is it 60 hertz?
60 hertz, 220 line to line, phase to phase.
Okay. Ooh, so that's going to be basically a North American type of a voltage. I mean, it's 10 volts off, but, you know, so now that's not the product we're speaking of today, but the RL is 230. So, Catherine, do we have a product for, this sounds like a North American product. We don't have a grid type product for split phase residential, correct?
Right, the RL you mentioned, also the 110 or 120 volts for North America, that's for single phase. But for three-phase, North America is still a 380. So for Brazil, if the line-to-line three-phase inverter, the three-phase, the voltage is 220, then I would suggest to consider a step-down transformer.
Right. Well, I think the thing is that we're talking split phase, not three phase.
That's clear. That's three phase, right? Your answer is very clear, Catherine. Thanks.
Oh, okay. It is three. Okay, but it's three phase. Then yes, a step down transformer. I agree. Yep. Okay. Any other questions? Well, I think that's going to conclude our morning seminar then. Please continue to come and again, thank you for your time and have a great day.